Last 128 class, in fact, the last day of this session at the college. After this is nothing but finals week. And I wanted to finish this chapter, so I decided to have a lecture on the last day, which I sometimes don't do. But anyway, that's what we're going to do. The last bit of attacking iOS applications. And unfortunately, there's no hands-on for this, as I've explained, because of lack of Apple hardware. But we're going to see it's a lot like Android, of course. There's not that much difference in general terms between the two. So we already talked about this, and now it's going to be the iOS runtime, interprocess communication, and injection. So the runtime is just like Android. Now, apps are not written in Java on iOS. They're written in Objective-C or Swift, which are C-type object-oriented languages. And so they're compiled to code, but there are decisions made at runtime. So it connects to libraries and API calls that are underneath it. And so apps can modify their own behavior at runtime through a process called reflection. They can dynamically node new classes and change method implementations. And for more detail of what that means, we can look at the object-oriented structures that are used here. So objects encapsulate data in the form of classes. Classes contain variables, methods, and properties. So here we've got an interface called a book. That's the class name. And that has things like pages and title and author. Those are data objects. Then it has methods that do things like get title, get author, and set author. And then a class method are things like create a book with a title and create a book with title and author. Okay, and so the instance methods are methods that are only available after you have created an object of this type. If you can have a period of time when you've defined a type, but you have not yet created any actual objects of that type. And you cannot use instance methods until you have created an instance of it, but you can use class methods just from having defined the class, even if there are no current instances created of it. Whatever difference that makes, not a huge difference from general point of view, but that's the point here. In Swift, it's similar. You have classes, instances, and class methods. The same general object-oriented features are available. So you can instrument the runtime, which is what we did in Android with Frida. What you can do is profile the execution of the app at runtime, and you can then modify the API calls it makes. So you can, for example, bypass jailbreaks, steal encryption keys, force load controllers like we did on Android. We would force it showing a page of an app, local authentication pivot to internal networks, which is really powerful. This is also done by DNS rebinding, and it's very important for Internet of Things devices because a lot of the devices in your house do not require authentication if you're coming from a local IP address. And so if I can trick your app into taking data from the internet and sending it out locally, I can attack your local devices and bypass the authentication of such devices. So Objective-C is the older iOS programming language, and it's easier to instrument. And so when you invoke a function, it creates a message and sends it through this Objective-C message send function. And so to instrument it, we just have to simulate calls to message send, and we can send signals that appear to come from the app. They call this method swizzling. This is essentially what we're going to do next semester in the exploit development function when we hook the library C pointers to cause calls to the C library functions to do something else, which is essentially what rootkits do. And so each class has a dispatch table, which is a map of pointers to methods, and all you have to do is replace those pointers, and it will now call other code instead of the expected code when it tries to perform API functions. And that's the point. So you can do it in Swift also. It's more difficult, but you can still accomplish the same thing. And this is what Cydia Substrate does. Cydia is the underlying structure that makes it possible for jailbroken apps to reach the Cydia App Store, which has all the apps that go on jailbroken iPhones. And Sork is the guy that did it. He created this runtime manipulation framework called the Cydia Substrate, so it lies below the apps, messing with the operating system, so the apps are now running in a modified version of iOS that lets you break all the rules. The most obvious one being you can install apps that did not come from the Apple Store and are not signed by Apple, because he's taken away those methods, or Trojaned them. And tweaks are another one. These are called substrate extensions. There's a tool to use a substrate C API to make them, and you can compile them and put them in there, and they will, again, modify the way the iOS operating system runs. Now, your extension, you probably don't want it to load in every process, so you define a plist file called a filter, which specifies which processes should load your extension. And so here's an example of the mdsec tweak.plist for some example from your book. And so here's the mdsec tweak, which will look for a process with just this name, lab1-1A. And only if it has that name will it load this extra library. You can develop your tweaks in various libraries. The best one, mainly recommended by your book, is called Theos. There are others that are older or more limited. This one seems to work best. And I wish I had hands-on projects where you make some stuff here, but like I say, for lack of hardware, I can't really do that this semester. Maybe in some future semester I'll be able to. One of my students was getting a job at the iOS virtual machine company. There is a company that makes iOS virtual machines, but they don't have a free version or anything yet. If we could get...
Is it called Corellium?
Yeah, Corellium. If I could have Corellium machines, if I could somehow get my hands on Corellium machines to give students, then we could be doing iOS the way we do Android.
You can do it. They have a free trial now.
They do have a free trial.
I signed up like 2 days ago for him.
2 days? Well, this is awesome news. So if you had a Corellium, some hands-on Corellium device we could use, then we could be doing this stuff in virtual machines for iOS the way we're doing it with Android, and that would make this course a lot better.
Maybe you can ask him how he get his hands on it.
Well, let's see.
If you go on their website, they have like a sign-up form, and they kind of ask you what you're going to use it for, but if you just say you're a pen tester, they let you in.
Request a free trial. Well, there it is.
It's really
So,
cool. I was playing around with it.
did you get a free trial?
Yeah.
Oh,
It took them like a day to authorize me, though.
that's not bad.
Yeah.
I'll have to check this out. So if this, okay, maybe next time I teach this course, which will probably be about a year, maybe you'll be able to do iOS then, if this thing works and it means.
The thing is, you only get like 6 hours of free trial time, and then
I was-
after that,
Yeah, I was afraid of
it's
that.
like, I think it's 25 cents per hour.
Yeah, okay, you only get 6 hours free time, and 25 cents an hour is not terrible. Some people might be willing to pay that, but it'll degrade, it won't, that's not incredibly impossible, pretty annoying though.
Yeah.
It'd be nice if I could get like an educational discount and get some more free, but anyway, maybe if I beg, I'll get it. It'd be worth
I didn't really look into it that much, but
Yeah, but I mean, I should try. That's a good point. Anyway, because we don't have any of that, we haven't got hands-on with this stuff, which is a shame. But anyway, so here's the key functions it has. You can hook function, find a symbol, get image by name, and hook message. These are the main functions that you add. So this one hooks native functions, and it uses a trampoline, which we've talked about before, where instead of having the function, the first command just jumps somewhere else. So it bounces off this and goes somewhere else to our replacement function. This will find symbols to help you decide what's going on inside your app. This will load a dynamic library, and this will implement method swizzling for functions that inherit from an object you specify. So those methods will now be using the modified methods. And so here's an example. Up here is, this is the C code, it looks like, probably, and so you get the substrate library, and then line 4, this old stat variable points to the original command stat. What this is going to do is modify the Unix command stat, a command line command that just tells you the status of a file. Nothing very exciting, but it's a simple command line command. We're going to modify it. And what this is going to do is if you are in the location bin bash, it will tell you there's no files there, no matter what. It will hide any files in that location. And otherwise, it'll just run the old stat command. This is how most rootkits work. You have a function which will most of the time will just do exactly what the original function does, and under certain conditions just hide things from you. That's the main thing rootkits do. They hide processes and network connections and files, so you can have secret things going on that your operating system and antivirus and everything cannot find. So that's a simple example of swizzling. And so it calls ms initialize, so load its contents, and ms hook function, which has 3 arguments: the symbol to replace, the new function, and the old function. So wherever anything refers to stat, it will take the pointer to old stat and replace it with the new stat. So it's a nice high-level language for what has to be written in assembly code if you're for Windows rootkits. All right, there's another thing called SciCrypt, which can be used to instrument iOS apps and can do a lot of these things like brute force authentication, steal authentic encryption keys, and force loading of view containers. So that would be nice. Now, here, this is the other issue. I mentioned the use in home environments with Internet of Things devices, but since many people bring their own device to work, which is very common now, most companies require you to have mobile device management, which is software you install on your device that will remote control it. And these things turn out to be very vulnerable and very nasty. So if they're vulnerable, then an attacker can hack into the internal network at your company through them or your home. And there have been quite a few of them that have come to have vulnerabilities. Kaseya, for example, makes one of these, and Kaseya had a vulnerability. There was a thing called Kaseya Secure Browser, which would let you into the internal resources with no further authentication. So if you compromised the mobile device, you could get in the internal resources at the company. There have been a whole series of vulnerabilities in these mobile device management apps. They're probably better now, but they've been around for enough years that I think their quality is improving, but they have had a lot of problems. And so Frida is the standalone instrumentation framework, which we've already used in Android, and it's very similar to use it in iOS. You don't have to modify the device. All you have to do is run the Frida server binary, which I think means you have to jailbreak it first. You run that on approved binary. So anyway, but now you can control by a client. And so this variable is another way to load this LD preload environment variable. On all versions of Linux, you can use to load a library into a process. And there's a similar variable in Mac OS and iOS. So you can specify a library to be loaded there. All right, and then there's inter-process communication, which I think are analogous to Android intents. So your iOS apps run in a sandbox, and they are not allowed to communicate between processes except through the clipboard, of course, which they call the pasteboard, or protocol handlers or application extensions. These are the ways for one app to communicate with another app. Remember, the apps do not run with different user accounts the way they do in Android. They all run with the same user account. So the protocol handlers have these things before the colon, a series of letters that are used to define the protocol. So ITMS-apps opens the App Store. You can define a custom scheme in your info.plist file, like you could define my VoIP : for your app, and then it'll take URLs that start with that and send them to your app. And you can add an iframe on a web page that automatically loads them like this, and this is what happened to Skype. Skype defined a Skype prefix, and people were able to make web pages that would just automatically make Skype calls. And on Android, they responded by making a box pop up to always ask you for permission whenever it makes a phone call. And I don't know what the defense was on iOS, but it might have been the same. And then there are application extensions. These used to be a ton of browser extensions we used, but I mean, here's some to find by Apple. Today is an extension to connect things to the notification center, so your app can pop up boxes telling you something about that app should happen today. Share or custom keyboard are other ones, naturally. And so here's how the extension works. You're sitting in your app, your host app. It makes a request to the app extension, and now the app extension goes out here and does something else, like open a URL and go to some other app, and then send some data back. So, use it sort of like a proxy. So 1Password uses an extension so other apps can query to get passwords off it, like Twitterific. So a malicious app could request credentials for any domain. But the one defense is when an app requests to pull a password from the 1Password app, it will pop a box saying, this app is trying to get a password out of there, is that okay? So we have some defense against apps just trying to take passwords that they shouldn't have. But as you've seen, yeah.
I think they also add extra, because I use 1Password, I think they add extra warnings now if you're trying to fill a password on a page that's different than the domain that's stored with it.
I would hope so, yes. That I was wondering, so they actually noticed the domain, hopefully. But the app could probably lie about the domain if it wanted to.
I guess. No, I mean like the domain of the page that you're actually on. And
Well, that's if it's going to a browser. Yeah, but what if your app is? Like Twitterific is not a browser. Twitterific connects to Twitter, and you log into Twitter.
Oh.
And most apps do that. They have an internal web view.
Oh, yeah.
And so that's the thing. I think you could easily make an app that lied about what domain it was. And but I mean, I haven't done it, but I'm suspecting you could. Anyway, and then there's injection. So tons of input comes in through web apps, URLs, files, AirDrop, beacons, Bluetooth, Wi-Fi, pasteboard. All these things are ways data comes into the phone, and of course, any of them is a possibility that there'll be some vulnerabilities you can exploit there.
What are beacons?
Beacons are the, well, I know beacons, normal beacons are what Wi-Fi networks use to announce the name of the network. iBeacons might be something else. Let's try that. That's a good question. What's an iBeacon? iBeacon technology. It's a good question. Here they are bragging about it, but they don't tell you what it is. It looks like it's something wireless. iBeacon gives your iOS apps the ability to determine their proximity to iBeacon-enabled hardware. I guess this is those things they use. They've been talking about this for years to detect when you're walking close to a store so they can pop up customized ads on your phone. I think that might be what this is, yeah. Yep, this is something like a Wi-Fi beacon to indicate proximity to something. But
when people say like those cobalt strike beacons, what is it? What are those?
yeah, Cobalt Strike beacons are the typical command and control malware beacons. A typical way malware works is they trick you into installing something on the device, and then the controlled device will send a beacon back home like every minute or so to tell the controller, I'm under control and wait for commands. So you can have a dashboard that says, I've got a Windows machine here, an iOS machine here, and you can select which devices to control. And so that's one way you often catch them. They send beacons out, but they try to hide them. They make beacon look like an HTTP or a DNS request on the network to try to hide it. So they're all very similar. And yeah, this guy says, Zoo says, iBeacon is to make Apple tags work, and it certainly sounds like that. This might be what the Apple smart tags use. It's a very good question. There are a lot of concerns about those Apple smart tags. Anyway, all right. And so they call it UI web views. In Android, they call it web view. In iOS, it's UI web views. Like I was saying, your app can render a web page. And so can anything else. And this is the underlying library used by all these things that render content. For HTML, PDF, RTF, Office documents, iWork documents. And this is what got Microsoft in a world of trouble. Like they had some universal image processing libraries that were used by every app, and they had vulnerabilities. So everything that handled images was vulnerable. And iOS has the same issue. It renders all these different kind of content, and some of these are pretty terrifying, like PDF. PDF has been the source of an extraordinary number of vulnerabilities because it is so complicated. You can put code in PDF, and many, many PDF vulnerabilities, and Office too. They're both very complicated formats that have had a lot of flaws. Anyway, so there's UI WebView supports JavaScript that can't be disabled, so that's cheerful. So you can do cross-site scripting, and you can bounce off it to steal content from the phone like the address book. And Skype allowed script injection into a user's full name. But if they just, any field they use that they don't filter for less than and greater than signs, you can inject things. So in the Skype iOS app, you're able to access the local file system and steal the address book out of it. Anything that app can get at, you could then send elsewhere. Of course, that was patched long ago, but it shows the class of vulnerability that happens. Now you got SQLite vulnerable databases, and as we saw in Android, these can be vulnerable to SQL injection, but usually that only gives you access to data. It does not usually give you command injection. You don't get total control of the device. With Windows, in old versions of Windows, there was this thing called XP command shell, so you could actually get a command shell through SQL injection. But that's pretty much disabled all the time now, and apparently there's nothing like it in SQLite. And then you can inject in XML. The main injection in XML is XML external entities attack, and you can define entities, which are like shortcuts that stand for other things, and the simplest thing is just define an entity that's like 10 copies of a word, and another entity to 10 copies of that, and another entity to 10 copies of that, so pretty soon you've got 1 billion copies of something and use up all the RAM and crash the server. So it's a simple denial of service attack, like a zip bomb. You can make zipped files maliciously defined so they will unzip to an unthinkable amount of data, like 100 trillion terabytes, so they'll crash everything that tries to unzip them, and that will crash forensic apps and antivirus apps and everything else that tries to unzip it to see what's in there. It's the same kind of thing here. And so that's an XML attack. And you might be able to get the file handling routines, things like directory traversal attacks. So if Joe can put a profile attack in some kind of documents Joe folder, then maybe they can change the file name to .jane and get into Jane's folder. If there's insecure direct object access, which is one of the OWASP top 10 vulnerabilities, where you know who someone is and you want them to stay in here, but you don't actually implement file permissions to make sure they don't have permission to access elsewhere. That's what leads to this, the two vulnerabilities together. The first one being that you allow them to put in suspicious characters like ... in a file name, and the second one being that if they do get there, there's not an access control list preventing them from getting access to things they aren't supposed to get at. The whole thing adds up to insecure direct object access, which is very common. So anyway, those are a few things that can go wrong, and let's take a look at a Kahoot. And, we're only seeing it at a high level. If I get my hands on those devices, maybe in a future version of this class, we'll have hands-on Apple projects again. We've had them a couple times in this course, but never had them work very well. I really need to be able to give everybody identical, what is this garbage? Oh, they've turned on some kind of garbage I have to click to get where I need to be. All right. App developers always want to show off their new things by getting in the way. Why do I hear nothing? Ah, there's the sound. Okay. We'll see if we can get some players. There are 9 people online, so there may be enough to make 3 players. Oh, look at this. I like the virtual machine running. Let me nuke that. All right. Aha, good. We got 4 players. That's good. I'll wait for the end of the song in case more people are coming. All right. All right, so which one defines a class structure? Okay, that's called an interface file. All right, so which one contains pointers to methods? The dispatch table, that's what they call it. In Windows, it's called the System Service Descriptor table. And in Linux, it's called the Global Offset table. Everybody has the same thing with a slightly different name. All right, where's what plist file controls when an extension will load? Okay, that's a filter, which is pretty much what it was in Android too. Remember those? You saw those go by in the manifest file. And which tool has JavaScript and Objective-C? Hard to remember this stuff without hands on. Script, yeah, you can sort of get it by elimination. All right. And which one always allows JavaScript? That's UI web views. It sounds like a bad thing, but in practice, who would ever turn off JavaScript anyway? What modern web page can possibly live without JavaScript? So, saying users should turn off JavaScript for security makes about as much sense as saying users should, you have a 12-character password for security and change their password every week and things like that. Nobody's going to do that. Anyway. Luca and Alexi, I know who that is. I know who that is, but it was other computer students, so it doesn't matter. All right. Well, that's it. I'm going to stop the lecture.